All right, let's get right into it. We're talking about cracking the sun's code here. For decades, scientists have been trying to predict our star's future, and it turns out the secret isn't in what's normal, but in its most wild, unpredictable parts, these things called rogue sunspots. So here's the big question, right? What is it about the sun's 11-year cycle that makes it so hard to predict? I mean, this is a rhythm that has a huge impact on us here on Earth, but forecasting how strong the next one will be, it's been a massive headache for scientists. Well, we're going to look at the breakthrough that's finally changing all that.
Okay, so to get this, you have to meet the main characters of our story, the sun's rogue actors. And listen, these are not your average, everyday sunspots. Nope, these are the outliers, the wild cards in the whole solar deck.
And you might be thinking, okay, why does this matter? Well, this is way more than just some academic puzzle. The sun's cycle is what drives space weather. And when that weather gets bad, we're talking about solar storms that can literally disrupt our satellites, knock out power grids, and completely mess with our communications. In our super tech-heavy world, getting a good forecast is, well, it's absolutely critical.
So scientists started to zero in on the problem. This quote from Petrove and Nagy really nails it. They pointed out that sometimes just a handful of these so-called rogue regions, ones with really weird properties, could be responsible for a huge, totally unexpected change in the sun's activity. Right away, these guys became the prime suspects.
Okay, so if these rogues are the problem, how did we used to try and predict all this stuff? Well, the old methods were, let's just say, incredibly complicated. We were trying to forecast a star that just didn't want to be predictable. For a long time, the main tool in the toolbox was something called a surface flux transport model, or SFT model for short. The easiest way to think about it is like a massive, super complex weather forecast, but for the sun. It simulates how all these magnetic fields are moving around on the surface. But here's the thing, this old method had a couple of huge flaws. First, the physics were, and this is the technical term, ill-constrained. That's basically a fancy way of saying that a lot of the key numbers they were plugging into the model were, well, they were just educated guesses. And second, it needed a ridiculous amount of data. We're talking detailed info on thousands of individual sunspots. Just getting that data was a nightmare. Okay, but this is where it all starts to get really clever. Scientists had a breakthrough. They realized, hey, what if we stop trying to do this super complex simulation and shift to something way more elegant, a simple summation? And this is the key. The old way, you had to solve this absolute beast of a math problem, a partial differential equation, for the entire surface of the sun. The new way, you just add things up. A simple algebraic sum of what each sunspot is contributing. It's such a radical simplification, it's almost hard to believe. And the craziest part? It works. Just look at this. That red line is the result from the new simple addition method. The blue line, that's from the old super complex simulation. I mean, they're practically on top of each other. This was the big aha moment. It proved there was a simpler way.
But okay, there was still a problem. Even with this much simpler math, you still needed data on all those thousands of sunspots. And that led to the next big idea. What if you could find a way to score just how rogue a sunspot really is?
So here was the challenge, right? The new summation thing was awesome, a huge step forward. But it still depended on having data for thousands of these active regions. How on earth were you supposed to sift through that ocean of data to find the handful that actually made a difference? Well, they came up with something called ARDoR. It stands for Active Region Degree of Rogueness, which is a mouthful, I know, but just think of it like a score. It measures how much a sunspot's magnetic personality deviates from the average for a spot of its size and where it is on the sun. So a really high ARDoR score, that means you found a true rogue.
And this right here is where the whole story clicks into place. By using this ARDoR score, scientists could finally stop trying to watch the entire crowd and just focus on the few individuals that were making all the noise.
Just to put this into perspective for you, in an average solar cycle, you get something like 3,000 active regions popping up. Trying to track every single one of them, it's a monumental task. But what if you didn't have to? What if you found out that the outcome of the entire cycle, the whole shebang, was really only determined by 5? Just 5. That is the heart of this breakthrough.
It's honestly like Moneyball, but for the sun. You don't need to waste your time tracking every single player on the field. All you need to do is identify those few key superstars whose performance basically decides the final score. It's the exact same idea here, Just track the superstar rogue sunspots.
And just look at this graph. This shows the absolutely stunning result. That solid blue line, that's the forecast you get when you do all the hard work and track all 3,000 plus regions. And that dotted red line, that's the forecast you get by tracking only the top 5 rogue sunspots, the ones with the highest ARDoR scores. They are almost identical. It is an absolutely mind-blowing discovery.
So, okay, what does this all mean for the future? Well, it's not an exaggeration to say it completely changes the game for how we forecast what's happening out in space.
So let's just quickly recap why this is such a big deal. First, our predictions are way more robust now because we're not relying on a bunch of educated guesses from the old models. Second, it's way less data intensive. You don't need perfect data on thousands of spots anymore. And that leads directly to better space weather forecasts, which helps us protect all of our critical technology. And maybe most importantly, it gives us this profound new understanding of our own star, that its huge, complex cycle is really driven by just a handful of these key rogue actors.
And that leaves us with a really fascinating question to chew on. If we can predict the behavior of an entire star just by focusing on its few most extreme actors, what other incredibly complex systems could we understand the same way? Think about it. Financial markets, climate patterns, maybe even social trends. It's a powerful idea.